so this is that promised video about how to do a cross product. Suppose that we wanted to solve a problem and we have this formula QV cross B. And we can't use the QVB sine theta because they give us V and B in component form. So for example, let's suppose they tell us the charge involved is 1.0 millicoulombs, or 1.0 times 10 to the negative 3 coulombs. That's not a vector quantity, so we'll save that for the last. What we really want to work on first is this part. And they tell us that the velocity of this particle is given by a vector. It is 7.0 I minus 6.0 J plus 3.0 K. Put that little times 10 to the 4th meters per second. Notice they only put this first part in the IJK format because all of that could be multiplied by 10 to the 4th. So again, we can kind of say this part for the very end also. Okay? And they tell us that we have a magnetic field that's given by negative 0.80 I plus 0.60 J. Again, these are those little unit vectors, I, J, K. I means that's how much it points along the X direction. J is how much it points in the Y direction, and K is how much it points in the Z direction. So there's our vectors. I just want to do a cross product for this. Now, one thing that makes cross products easier are zeros. There's not a K part here, so that's going to make it a little bit simpler. But I didn't want to get one where lots of stuff canceled out because I wanted us to be comfortable with how that's going to work. So we start with, or I like to do it, to think in terms of V cross B is going to equal, and I make this big 3 by 3 vector. There's I, there's J, there's K, and then I put in the components for V. That's going to be 7, negative 6, positive 3, negative 0.8, plus not plus 0.6, but positive 0.6, and 0. I'm going to save this times 10 to the 3rd later and just tack it on at the end, just like I'm going to save this 1 times 10 to the negative 3 microcoulombs. So I just really want to talk about how do I do, if this is my problem, let's say that wasn't even there, how do I do V cross B? All right, I'm going to erase all of this to give myself working room. I'm going to put this matrix up here in the corner because I'm going to refer to it a lot. I, J, K, 7, negative 6, 3, negative 0.8, 0.6, and 0. All right, how do we do that? Well, if you want to know the answer, I component, what you have to do is in your mind or physically, if you're trying to find I, you're going to cross out this and this. and it will equal a determinant negative 63.60 in the I direction. Okay, that's going to give me, once I take this determinant, that's going to give me the I direction. Let's get the J direction. Well, to get the J direction, this second part, I'm going to put it in red, is actually we always subtract. I don't know why. I only know that that is the rule. So minus, and again, we take out this row, and now take out this middle row. We want to use these. So this determinant is 7, 3, negative 0.8, and 0. That's going to be in the J unit vector. That's along the y-axis. And then our third one is going to be the K. So in this case, we don't use this, but we don't use the K column. We use these two columns. So my third one is going to be plus 7, 3, negative 0.8, 0, and barely squeeze it in. That's in the K direction. Okay. This is going to give us our vector that's equal to V cross B. Now, if you know how to put a 2x2 matrix in your calculator and go under matrix and do math, you can just ask it to do a determinant on this 2x2 matrix and it'll give you the number. It's really pretty easy to do. Same thing here. Do the determinant of this, just keep this minus sign out of it, subtract this quantity. But if you don't know how to do those determinants, they're really not that hard to do. So I'm going to show you how to do the determinants. So we're looking at V cross B. It's going to equal, when you do the determinants, you're multiplying negative this. So negative 6 times 0 minus this, 3 times 0.6, and that's going to be in the I direction. Well, that's 0. Minus 3 times 0.6, that's minus 1.8 I. So I did that determinant. Minus, because this is a minus, I'm now going to do this determinant. It's going to be 7 times 0 minus negative 0.8 times 3, or 3 times negative 0.8, 3 times negative 0.8. That's in the the J direction. Well, that's 0. That's 2.4. So minus 2.4. This minus this, that all came out actually to be positive, minus again. So minus 2.4J. And we do the same thing. This one's a plus again. 7 times 0 is 0. Minus, so I get 0 minus 3. Oh, wait, how did those two come out to be the same? This is a mistake. I lined out that column. That should have been 7, negative 6, negative 0.8, 0.6. So let's fix that right there. If you caught that early on and I caused confusion, I'm really sorry. Let's just do this last one completely over. When I take out this column, I'm left with 7, negative 6, negative 0.8, 0.6. And that's going to be our K component. Okay, so let's try that third one again. I'm going to do 7 times 0.6. Well, 7 times 0.6 is 4.2 minus negative 0.8, negative 6. That's going to be positive, minus times a minus, 4.8k. 4.2 minus 4.8 is 0.6, oh, it's negative, k. Those are those unit vectors. So there we are. Now, we took some stuff off. Remember, these velocities were times 10 to the fourth, so this is really times 10 to the fourth. So, if I want to find the force, F equals Q V cross B. And Q was, I believe, 1 microcoulomb is what I said. Let's assume I said that 1.0 times 10 to the negative 3. That's a microcoulomb. And of course, negative 1.8 I minus 2.4 J minus 0.6 K times 10 to the fourth. Well, 10 to the negative 3 and 10 to the fourth, that just multiplies to equal 10. So the whole thing just is going to come out to be times 10. So that's negative 18I minus 24J minus 6.0K. And it's force, so the whole thing will be in newtons. You should have a handout that I gave you that gave examples of how to do a cross product. If you Google it, you can find lots of examples on the internet as well. But hopefully this gave you a little bit of a reminder on how to do it. If you set it up with IJK, this is, in this case, the first vector. This is the second vector. To get the I, take out this, and those four become your little determinant here, your little matrix. Minus on the second one, just because that's the rule. Take out those two, 7, 3, negative 0.80. There's our second little matrix. That'll be in the J direction. Our third matrix, we take these two out, 7, negative 6, negative 0.8, 0.6. There we go. This one's back to positive. And then you're always, when you're doing this, you're multiplying these two multiplied together minus these two multiplied together. Okay. Or you can play around on your calculator and it will help you do all of those little determinants if you can set it up correctly. If there's other numbers like Q, you can multiply by that later. That 10 to the fourth power on that velocity, you can multiply by that later. Just want to make sure you know how to solve a cross product. If you have questions, you can always email me and ask about it, and I'll see you in our Collaborate meetings.